Hi, everybody. This is Priyanka, and I'm going to be speaking about distributed tracing today. Unfortunately, I am not in person, but on a video camera. That's because I couldn't get my visa in time to come to Brussels. Well, I hope you guys are having a wonderful experience, and I'm so jealous I'm not there. Anyway, with that said, let me share my screen and start my presentation. Share. I'm going to share the Google Chrome. Start. So I'm hoping you can all see my screen right now. I'm going to hit present mode. All right, so, oops, that's my mother telling me she loves me. That's great. All right, wait, I'm going to stop sharing and turn off notifications. Okay. Resume share, present mode. All right, so as I said, this is a talk about distributed tracing and an update on the ecosystem around it in 2019. I am Priyanka Sharma. I'm Director of Cloud Native Alliances at GitLab. GitLab is a single application for the entire DevSecOps lifecycle. I'm also a board member on the Cloud Native Computing Foundation, which is the home for Kubernetes and a slew of other projects that are related to going cloud native or building workflows that relate to cloud computing. So example, the second project after Kubernetes to join the organization was Prometheus. The third was Open Tracing, which I was an early contributor of, and then Jaeger, Envoy, et cetera, et cetera. So that infrastructure part of the world is closely aligned with Cloud Native Computing Foundation these days. You can find me on Twitter at this handle, which is Priyanka. I am constantly on Twitter, so you're likely to get a response really fast. But there are other ways to reach me, like email, which I share at the end of this presentation. All right, so without further ado, let's go to the next slide and get started. Intro to distributed tracing. Now, if I was there in person right now, I would ask how many folks are familiar with distributed tracing in the audience. I'm hoping some of you have heard of it at least. We'll start at the basics, so don't worry. Before we talk about tracing per se, let's talk about the environment we are in today and how it fits in. So, as many of you know, we used to develop software monolithically. It was all a large box and requests would go through it. It was easy to see what was happening and debug problems when they occurred. With the advent of cloud computing, things changed. We started putting workloads into the cloud, started using containers, and then along came Kubernetes, which made container orchestration really easy. So along the way, what happened is that small teams started breaking out to build services, which were parts of the monolith just shaved off, which could be independent so that they could ship faster. Independent teams could build features that were related to their aspect without being concerned with the rest of the system. And as your traffic grew, you could scale out much better. So that was really great, right? However, what this also means is that now software is being built completely differently. When that is the case, as you can see in the diagram here, there are many, many pieces, and a request goes through all of them, and a response comes out, and it's not necessarily clear what exactly happened. There's fragmentation. There's a lot more data because, as you can see, there are a lot more edges and nodes. There's also teams. The benefit of having lots of services and teams independently working on them is things move faster because they don't have to talk to other people that much. But the negative is that teams get siloed and operate in their own worldview, which leads to operational issues and really bad mean time to resolution when problems do occur. Yeah, so the operational issues is where we'll be focusing our conversation today. When we built on monoliths, it was not as efficient, but we'd been doing it for a while, so we were very good at the tooling around it. Once microservices came into play, we started shipping faster and getting all the benefits, but we do not, till date, have the best practice on tooling, and so it's possible that you'll split things up to two services, and then those services just topple over on the operational mismanagement. In this world, observability comes in to help us manage the problems that we see. When you think of observability, you can it's a buzzword in some ways. It's become a thing in the last 2 years, I would say. It really is, in my opinion, and everybody's opinion around observability is like slightly fluid. In my opinion, observability is a superset of the various techniques that will help you reason about your software system and respond to issues. So the 4 pillars that it consists of are metrics. Very related to metrics are alerts, traces, and then logs. When we think of metrics, these are simple counters, right? That these events are happening. Like there's X amount of 404s. Alerts are, hey Priyanka, there was a 404 on this page that you work, which is part of your responsibilities. Tracing is knowing when that 404 happened, what was the path the request took and the pieces it went through. Logging is timestamp logs, which we are all very familiar with, and that's been the same since the monolithic days, except just the volume of logs is increasing. So these are the pillars of observability that help us reason about our systems. Metrics, alerts, and logging are out of scope for this conversation. This is meant to be a tracing talk, so we're going to focus on that. Let's keep going. So what's distributed tracing? As I said, I would love to be interacting with you guys right now and ask who in the audience knows what tracing is. Does someone want to define it? But we will just keep going because this cannot be as interactive as I'd like. So tracing is really following the path of a request from start to finish when the response comes out. It's the view of the life, right? And this diagram that I have here, I've pulled, and the definitions here are pulled from a paper called the Dapper paper, which Google released back in 2010. And the paper described the technology that Google had built, and it does a really, really good job of explaining what is tracing and then also how they executed on it. So that's the TLDR of what a trace is. Don't worry, I'm not going to leave you there. There's obviously more to it. It takes some time to internalize the concept. So a good mental model is like, there are a few aspects, there are 3 components of a trace that are important to know. So here's a visualization that you can see where you have the parent span, which has a bunch of child spans, and you can annotate said spans with logs or whatever you want. And you have multiple services have their own spans, but these services talk to each other, and that's the network call. So when something goes from service A to service B, the span context transfers, and that's how the whole thing is a trace. So a trace is a recording of a transaction as it moves through a distributed system. We already discussed this. So traces are DAGs, they're directed acyclic graphs, which means that they are directional in nature. There's a time frame and a direction in which things are happening. And these traces are made up of spans, as we discussed. And a span is really like start, stop. That thing is a span. It's a named timed operation representing a piece of the workflow. They have a timestamp and duration, as I said, and they can be annotated, which is really, really useful when you implement tracing into your system. You can have tags, you can have logs, and different systems may call them different things, and we'll get into that mess a little bit later. But the TLDR is that you're able to put information in these spans. Span context, as I mentioned, is how information goes from service A to service B to tell us that this span A and span B are connected and part of a larger trace. Trace identifiers or trace ID are injected into each network request, and the next service will extract it in order to propagate the trace. So this mental model is really useful when you think about tracing and what it is. I'll give you guys a second to just look at the diagram and internalize it and maybe read the definitions. These are going to be really useful for you as you consider tracing for your system, where you work, or for your own applications, whatever your situation may be. All right. So let's keep going. This is an example trace and visualization. So here is what is actually happening. Through the client, a call was made to the web server, it went to auth, it went to billing, it went to the database, and then you get the response out and back to the client. And in the visualization, as you will see here, you have the client, web server, and like you see the amount of time that's spent on all. So in this trace, actually, it's really interesting because when you look on the left side, auth, billing, database, everything looks kind of the same, right? But when you visualize it with the time context, you see that actually billing takes a lot of time because there's sub-processes in here. And you see the database is the fastest and most optimized. So these are good pieces of information to have when you're debugging, because this tells you where was the actual holdup. So now that we've talked a little bit about what is tracing, I want to get into the next piece of this conversation, which is around what has been happening in the tracing landscape. Now, again, if I was there in person right now, I would ask you how many folks are currently have their systems instrumented for tracing and use it regularly. And then I would ask you how many folks have played around with tracing. And then I'd ask you how many are just curious. I have no way of knowing that in this video, so I'll keep going. But given what stage you are at, you may or may not know a little bit of the history of the open source projects that I'm about to cover. My objective with this part of the talk is to discuss the ecosystem of tracing, what is going on in it, and also how practitioners can move forward knowing what's the latest and greatest. So let's look at the history. Now, tracing as a concept has been around since the 70s. There were a lot of academic research on it, lots of papers written, etc. Google's Dapper is one of the first implementations in industry, at least ones that we talk about and discuss. And primarily this is because Google released a paper on Dapper, which, as I discussed, came out in 2010, which described the methodology that they used to build Dapper. This paper was pretty seminal. One of the writers, Ben Sigelman, I used to work for him, he jokes that they thought it was a crappy paper because none of the academic conferences accepted it. However, in industry, it really took off. Zipkin was built at Twitter based on Dapper, actually. And in 2009, it was open sourced. Zipkin was basically the first open source project out there that allows you to do tracing. And then there was a large gap. As you can see in my timeline here, we have nothing happening for a bunch of years until 2016, when open tracing was born. So, Zipkin, just to be clear, is a tracing system. That is where you go look at traces and they've been collected and all of that stuff. Open tracing in 2016 came along as not a tracing system, but rather addressing a key problem in why distributed tracing was not getting adopted, which is that instrumenting your code to get traces is a tedious job, and only the few biggest companies had invested in it till then. So open tracing was aimed to be a de facto standard, a set of APIs and libraries for people to use depending on their language to have standardized sort of pipes and tunnels built into their code that a tracing system could pull data from. Open tracing I was part of it since the very early days, and I think it really changed the tracing landscape. And I am biased because I've been part of it, but the reason I think it has really changed the tracing landscape is because it shed light on the real problem, which was that who has time to instrument all of their code? And not only was it an API standard and best practices, we pushed really hard to get open source projects to incorporate the open tracing library into their code, so that users of open source projects could automatically get tracing when they wanted to. This was a big deal simply because, as you all know, I'm sure, much of the code in applications today is OSS with glue business logic in there. So that was big. Shortly after open tracing came Jaeger tracing. Now, I'm a little fuzzy on the exact timelines when Uber started working on Jaeger, but Yuri, the lead person on Jaeger, was also a lead person on open tracing. And Jaeger tracing is, like Zipkin, a tracing system where you can see and visualize traces. So that was cool. And Jaeger today is like actively maintained, does really well. There are lots of like actually case studies that are coming out soon about people who've been using Jaeger. So watch out for that on their blog. Now, along the same time, after tracing and open tracing and Jaeger were around, came the W3C wire protocol format working group. This one is more relevant to the vendors and open source tracing providers than it is to end users, because this is about agreeing on a standardized wire protocol format so that it's easier for the vendors to interoperate. I will not be focusing much on this one because my focus is the practitioners in this conversation. And then in 2017 emerged another project called Open Census, which came from Google. Open Census is bigger really than all of the than just open tracing's mandate or just Jaeger tracing mandate. Open Census aims to provide libraries for instrumentation for tracing and metrics. So it expands the scope. If we remember the pillars of observability, you might remember that we had those metrics, alerts, tracing, logs. And what Open Census is very ambitiously trying to do, and I think it's commendable, is trying to put all those things together with the same project. And so clearly it's way beyond open tracing's mandate. In addition, they also have an example tracing system. I think it's called Z Pages, which will help you visualize your results. So that came on around 2017. A lot of those people were people I met and interacted with while I was working on open tracing, before Open Census was born and after Open Census was born. Anyway, so that came along in 2017. And now at this point, we're at a stage where there are tons of vendors in the space. Somehow tracing really took off in the last couple of years. And I mean, it's not a somehow, it's because when you are working with distributed systems, it's very critical to have some form of tracing to really understand what is going on. But tracing got popular, lots of vendors in the space, lots of projects in the space. And now there are these open tracing, open sensor, wire protocol format, these core building block foundational projects, which are confusing a lot of practitioners about, okay, what am I supposed to do here? Where do I go from here? As I said, people are getting confused, and I see 2017, I should say, as the era of confusion, not because it's bad that there's more engagement in this space, but rather because these projects seem competing. And as somebody who has been involved in the space, I'll tell you, I felt that way. I also felt that a lot of us were wasting a lot of time. We could all just work together. And the good news is I realize now that that's what everybody wants. So, and we're all moving in that direction. So as I was saying, there's a lot of vendors in the market. On the left side, I have all the vendors that are proprietary. And on the right side, I have folks that are open source. And so as you'll see, largely free. This is not even a complete list. So I can imagine as practitioners, you folks listening to this conversation here, considering tracing, it's like, well, okay, what do I do? Like, which one do I go with? What's my answer? Your open source projects are not telling me what's really going on. So what do I do? I hear you. This is why I came to give this talk. I wanted to introduce people to distributed tracing and also talk about what's going on and how we can move forward together. So let me specify the confusion again. There are three stakeholders whenever it comes to tracing. There's the vendors, OSS or otherwise. There's the open source project leaders who I discussed are critical to the story, because when you're trying to understand the process, the path through which a request went, it obviously went through a bunch of open source code, and you need to account for it in the story. And then obviously there's the practitioners, you all and myself, who just want to get going, understand our systems, and keep building awesome things. So all these people have different layers of confusion. So from the vendor perspective, which instrumentation option should I choose? Should I be Open Tracing compatible, Open Census compatible, both compatible, build my own thing? What's the right thing to do? Then how do I navigate W3C? What should I push for? And there's a lot of conversations happening here, so I don't think people are being shy. So it's all good. Then on the open source leaders, excuse me, front, there's a conversation around, which instrumentation library should I add in my project? Should I go with Census? Should I open Census? Should I go with Open Tracing? Should I care about this? Is this too fragmented of a space for me to bother right now? And then, of course, the practitioner story we discussed, like, what's the best way to get started? Like, someone tell me what's step 0. And then if I do like what I'm doing, what vendor should I choose? Like, there's too many questions. And unfortunately, at least in the last few years, there's been an increase in confusion rather than a decrease. In this talk, unfortunately, the vendor and open source leader questions are out of scope. We have only so much time. I'm almost at 20 minutes already. And I'm going to just focus on what should the practitioners do. Well, there are some best practices I can suggest to you. Step 1 is take your time. If you're not in a rush, if your system is currently not experiencing too much concurrency, you're not seeing that many problems, take your time. As I said, we're achieving almost peak confusion, but all the indications are that there will be consolidation in the space in a good way. I can tell you, Open Tracing and Open Census have like the channels of communication are open. CNCF is being a great steward and making sure that the projects are communicating about next steps and making sure that people don't duplicate work, and the 1 + 1 is greater than 2. So there's going to be more information in this space. I had expected that by the time I give this talk, a lot will have changed, but we're still a work in progress, which is fine. At least the work in progress is there. Second thing, take incremental steps. So at GitLab, we wanted to get going with tracing for our own system, and we were trying to figure it out. So I should say, my teammate Andrew Newdigate, who also happens to be the founder of Gitter and is a GitLab teammate now, he was tackling it. And he started with first principles to solve the core problem. What's the core problem? Developers who are building on the GitLab developer kit, which will be everybody in the company, but also beyond, they need more visibility into how things are going. And so he was like, that was the core problem to solve. But at the same time, currently, not everybody is aware of tracing or looking at tracing, etc. So we need to build interest in the team. So he looked through all the options, and the choice he made, and I'm not saying this is the choice to make, I'm saying this is a choice that was made that looks pretty good to me, is that he instrumented the GitLab developer kit with Open Tracing. And he also wrote a library called LabKit that would allow for multiple tracers to interface at the same time. Currently, we're using Jaeger because we're in the build interest in the team phase right now. And Jaeger is awesome, but we want to spend time using it and then seeing if we want to, for certain aspects, add different tracers or maybe just keep Jaeger, whatever. We need to have our options open and not commit to something right away, especially since we're like proof of concepting it. And so that's the choice we went with. In the process, Andrew ended up developing this library called LabKit, which is open source and people can check it out. I've linked to the demo he did of distributed tracing with Jaeger and the GitLab development kit. Feel free to check it out if that's interesting to you. Then finally, iterate. Assess the results regularly and make changes. Andrew just released all this, so we're not in assess results stage yet at GitLab, but we are very iterative as a company. I mean, minimum viable change is our mantra. So we will be looking at the results and seeing, do I want to try different tracers? Am I happy with what I have? Do I want to instrument some things that are not instrumented? All those questions can be answered as you go incrementally. And I have a quote here from Brendan A., who's director of platform architecture at T-Mobile. I interviewed him on a panel at KubeCon Seattle, and we were discussing tooling in cloud native, which all this kind of relates to, right? And we were discussing, how do you pick the right things when there's just so much so much cacophony in the ecosystem. And his point of view was like, look, there's dozens of tools for a single use case. And we saw how many tracing options are there. The devil is in the details in terms of what they provide, but there's options. And so when there's so many options, fail fast. If Prometheus 1.0 didn't work, look at 2.0. It might deliver quickly. And the key is not to get married to your tools and not be too sad if they don't work out, because there's something that's going to work. We're all, as an industry, working to improve, and you're not going to be left in a lurch. The flip side of that is that there's often confusion and cacophony, but hey, one is better than, it's better to have innovation than not. So that was my talk. I know we covered a lot of stuff, and we're pretty much out of time now. Thank you so much for coming and listening. And thank you so much for bearing with me being on video. But I hope you found this session useful. I am actually around right now. I'm on Twitter @Prityanka. You can ask me questions there, or you can email me, or however you like to contact me. Feel free. I will be around on Twitter if you want to start asking questions. Thank you so much, and I hope you enjoy the rest of Fosdem. Bye.